So remember, in all of our videos so far in this section, you always had to check your answers. And now we're going to get into why. So there's something called an extraneous solution. So an extraneous solution is where algebraically it will solve and be correct after you do some steps, but then when you plug it back into your original problem, it gives you an answer that doesn't work. All right. So when we start raising, when you raise each side of the equation to the power, so when we start using powers, we can start adding questions or answers that might work algebraically from that point on. But when you plug it back into the original, it may not work. All right. So we need to be careful with this, and we need to check our answers. All right. So we're going to go through this problem first. Now, here you may see a radical equation where it's written as a radical. But if you notice, it's raised to a power. So what I would suggest you do, just because it's a little bit easier, is rewrite it as a rational exponent. Because then you can see exactly, so power over index, so it's 3 over 5 plus 1 is equal to 24. Because now you can see exactly what you need to raise each side power to. You can leave it in radical form, and it will just take you one more step, but you can rewrite it as a rational right away. And then same thing, you want to isolate it like we've done before. So we will subtract 1 from, this is equal to 25. So you will subtract 1 from each side. So then we will get 3 times x plus 1 to the 3/5 power is equal to 24. Then we will divide each side by 3. And then we'll get x plus 1 raised to the 3/5 power is equal to 8. And then, in order to get rid of this rational exponent, we need to raise it to the reciprocal power. So 3 over 5's reciprocal is equal to 5 over 3. So we'll raise it to the 5 over 3 power. And what we do to one side, we have to do to the other. And here, since we're multiplying, our numbers cancel out, and we're left with x plus 1. Off to the side, 8 to the 5/3 power. It's power over index, so we know it's the cubed root of 8 raised to the 5th power. Now remember, it's easier to work if you can take the radical first. It's easier to do that because then you're dealing with small numbers. And the cubed root of 8 we know is 2, and 2 raised to the 5th power is 32. All right, so then we know x plus 1 is equal to 32, and then we'll subtract 1 from each side, and we get x is equal to 31. All right, now remember we need to check our answers, so just make sure you get in the habit of doing that. So 3 times the 5th root of 31 plus 1 raised to the 3rd power plus 1 is equal to 25. So then it's 3 times the 5th root. So remember, it doesn't matter if you take your root or your power first, so I'm just going to write the power on the outside so I can take my root first. Plus 1 is equal to 24. So the 5th root of 32 is 2. So 3 times 2 cubed plus 1 is equal to 24. We're asking ourselves, does this actually equal? And 2 cubed is 8. 3 times 8 is 24. So 24 plus 1. Keep writing 24. Does this equal to 25? Does this equal to 25? So 24 plus 1 does in fact equal to 25. So yes, it works. All right, so it's not an extraneous solution. All right, one more example and then we're done with this video. All right, remember, radical equation, check for extraneous solutions. So the first thing we want to do, just like we did before, is we want to isolate the radical. Now, if you notice here, we do have a variable on the other side. So we're going to add 5 to both sides, and we would get the square root of x plus 7 is equal to x plus 5. All right, now to get rid of that radical, since there's no power and it's just an index, we can just raise it to the same power as our index, so we just need to square it. If this was 3, we would have to cube it. If this was 4, we'd have to raise it to the 4th power, and so on. All right, so what you do to one side, you have to do to the other. So now we're left with x plus 7. But here we would have to multiply x plus 5 times x plus 5. So we would use FOIL. So we would get x times x is x squared. X times 5 is plus 5x. Change color for the other number. 5 times x. So 5 times x is plus 5x. And then 5 times 5 is plus 25. So then this will multiply to give us x squared plus 10x plus 25. Now, ask yourself, what type of equation do we have? We have a quadratic equation because we have an x squared. And we have to set this equal to 0 in order to solve. So we need to subtract over x and subtract over 7. So subtract over x and subtract over 7. So we'll get x squared plus 9x plus 24 is equal to 0. Now remember, it does not matter which method you choose. I'm sorry, not 24. Plus 18. Right, now, it does not matter which method you choose. Meaning, you can use quadratic formula, you can complete the square, you can do any method that we've learned in an earlier chapter. This one is set up easy for us to factor. So I'm going to factor this out. I'll write my two binomials. This means they're the same. This means they're both going to be positive signs. X squared always factors out to x and x. Numbers that multiply to 18 that add to 9 are 6 and 3. And then since both of these multiply to give me 0, I can set them both equal to 0. And I will get that x is equal to -6 or x is equal to -3. All right, so remember, now we need to check both of these answers. So, does the square root of -6 plus 7 minus 5, does that in fact equal to -6? Well, the square root of -6 plus 7 is 1. So the square root of 1 minus 5, does this in fact equal to -6? Well, this is 1 minus 5, does this equal to -6? And no, 1 minus 5 is -4, which does not equal to -6. So right now we know that that is an extraneous solution. So you would cross that out. It's not a real solution. So then we need to try -3. So the square root of -3 plus 7 minus 5, does this equal to -3? Well, -3 plus 7 is 4 minus 5. Does that equal to -3? So it's 2 minus 5. Does that equal to -3? And -3 does in fact equal to -3. So our only real solution for this one is x is equal to -3. So x is equal to -6 is an extraneous solution where when we were solving algebraically, it came up as an answer, but it is not a solution. And that is it for this video.